In the previous video, I mentioned some prerequisite knowledge required for this series to be useful. Today, we're going to be looking at how to use those concepts in Java, the Java syntax. So let's start with the basic Hello World program, the program to output some text to the screen. And you can see that in Java, as compared to some languages like Python, we've got a lot more going on here. And that's because Java is this primarily object-oriented language. We need to do a lot of things just to get something up and running. If I add some new lines here, we can see that the equivalent to Python's print hello world is this system.out.println hello world. And if we run this program, we can see that we get the result here. But what's the rest of this stuff going on? So we've got a public class. Now, this public doesn't strictly need to be here, but I think it really should be. We've got class. We're going to leave that for later on. We've got print, and I've just called my file print.java, so you can see here. And so the class name needs to match up with the file name. And then we've got here the main function. We'll go on to how to make your own functions later on. But yeah, this is what it looks like in Java to create a function. And in Java and in a lot of different languages, the main function is a function that will be called at the start of the program. So when you run the program, the main function is called automatically, and that's how you start the program. In Python, you can just start writing lines of code, and then when you run the file, everything will be executed. But with a lot of languages, Java included, the starting code needs to be inside the main function. Java is a statically typed language, and what this means is that if we want to create a variable, in Python we could do something like num equals 5. And in Java we're not allowed to do this because we need to say what data type the variable is going to hold. So in this case, it's going to be an integer. So we need to do int num equals 5, and then we're going to need to add semicolons to the end of the lines as well. Semicolons are a bit strange if you've not used a language that also uses them, but once you get used to them, they are just second nature. And in fact, when I first started using semicolon languages, I started adding semicolons in non-semicolon languages like Python. But again, once you get used to switching back and forth between languages, that will become second nature. Same with the brackets instead of the indentation that Python uses. I actually think that the brackets are a lot nicer than Python's indentation. Because you won't have errors because you have an extra space on one line. But okay, so we've got a variable here, and it's giving us a warning. Now this warning is saying we haven't actually used the variable, so we might want to take it out. This can be a bit annoying, but if we do plan on using it, then we can just ignore that, or even just come down here and add a system.out.println with the variable. And now the warning goes away because we've actually used it. And if we print this out, we can see the 5. And we can also do num plus 1 because it's an integer. We get 6. We can create variables of other types as well. So if we want a Boolean variable, we can type in the word Boolean. Now, a lot of languages will use just the shortened version bool. In Java, we need to use the whole word Boolean. Okay, so maybe this is going to be condition. And in a language like Python, I think Python is the only one that I know of that does this. We would type true or false with a capital at the start. In Java, we need to use a lowercase, and we're getting this warning again to say that we're not using it. So why don't we just print it out again? And we get the value true down here like this. If we want a string variable, we can do that as well, but the type is going to be a capital S string like this. So maybe we want prompt, prompt equals hello, and we can print this out just the same. Now, I've missed out the P. That's why it didn't look right. Okay. Prompt. Okay, so string uses the uses a capital letter at the start of string because it's a little bit different to the other data types that we've seen so far. Boolean and int are both primitive types. String is a bit of a different idea. We need to have a collection of characters. And this is all handled by Java, but it uses a class. Again, we're going to see these later on, but that's why string has a capital letter at the start. It's to differentiate it between the primitive types and a class. Now, a character is different to a string, so we can also have a char. Char C equals H. Now, this time we are using single quotes to represent a character, whereas with a string we have to use double quotes. In languages like Python and JavaScript, the single quote and double quote are completely interchangeable, but in a lot of languages, the double quote means string and the single quote means character. So to show you that these are different, if I was to add another letter here, we can say that this is an invalid character constant. This needs to be only one character. And we can print this out as well, just the same, and see the result like that. If we want to represent a decimal number, we can use the type float, and maybe this will be dec for decimal number, and that will allow us to do something like 5.5. But there's something going on here. Type mismatch cannot convert from double to a float. So in Java and a lot of languages, we have floats and we have doubles, and they both represent decimal numbers. We also have another type called long, which is a long integer. So what does all this mean? Well, in Python, you can just create a number and make it as big as you want. And in order to represent that inside of the computer, we need to assign memory in order to represent it. Python will do some fancy business behind the scenes and just use as many bits, as much memory as it needs in order to represent that number. But in most languages, we're only given a certain amount of bits to use. So if I just comment some of this out, and we can do that with a double slash. Let's create another integer, and let's call it max. And let's set the value of max to be integer with a capital I. And so this is a class. This is slightly different from the int primitive, but they are associated with each other. And let's do dot, and here we go, max value. Let's just print this out. Okay, so we get this very large number here. What is that? That's about 2 billion. And so what if we were to do the maximum value that we can possibly represent plus 1. You can see that we get a negative value here. And so what's happened is, in order to represent a negative number, we need to do that in a certain way, and it's called 2's complement. I'm not going to go into too much detail right now, but if we have the maximum possible value that we can store, and we add 1 to it, it takes us into what we've assigned to be a negative value. And that might make very little sense if you don't know what 2's complement is. Basically, all we need to know is we only have a certain amount of space. Some of it is dedicated to negative numbers, and if we make our integer too big, then we overflow into this false range. And so what if we want to represent the number that is about 2 billion plus 1? Well, that's where the long comes in. In a long, we have twice as many bits available. So if we do long max equals integer.maxValue plus 1, this is an integer and this is an integer. We add these together, we get an integer result, and then we assign it to a long. Let me just correct this by doing long, so we can convert integer.maxValue into a long, and then we can add 1 to it. And now we get this value of about 2 billion plus 1 from what we can usually represent. Okay, so if we want to represent a float, one way that we could do that is by adding some brackets at the front and converting this into a float, just like we have up here to convert this integer into a long. There's also a different way that we can do this. We can take out this here and add an f at the end, and that also converts this into a float type. It does something slightly differently, but we don't need to worry about that for now. And then we can also just come down here and print this out as well. But this is going to have a similar issue. It's going to have a maximum possible value. And because we're representing positive numbers and negative numbers and decimal numbers as well, the likelihood that we're going to run out of bits becomes quite high. With an integer, the likelihood that we're going to need a number bigger than 2 billion isn't that high. Whereas the likelihood that we're going to need a double, which is a float with twice as many bits available, the likelihood of us needing a double is actually quite high. And so when the creators of the Java language were designing integers, longs, floats, and doubles, they decided to make doubles the kind of default. And that's why if we add dec2 equals 5.5 and add in semicolon there, this value, unless we have an f on the end, will default to a double instead of to a float. And so these are the most important data types in Java. Again, we don't use longs or floats very often, so we can just focus on integers, doubles, booleans, characters, and strings. And one more thing about variables is if we want to use multiple words in our variable names, so maybe we want to change this to my prompt instead of prompt. You see here I've used a capital letter at the start of the second word. Now in Python, it is standard to separate different words with an underscore. But in Java, we use a capital letter at the start of every new word except for the first word. So this first one is often known as snake case, and this one here with a capital on every new word is known as camel case. Either would be fine. If I was to change this to underscore, I believe it should work absolutely fine. Yep, here we go. But it is just standard to use camel casing for Java. Okay, so for if statements, we're going to need a condition. So let's have a Boolean variable condition equals true. We don't need to have this as a separate variable. We could do if true instead of this condition here. But let's separate it out to a variable. And so what we're going to need is some curly brackets like this, and the condition itself should be wrapped in normal brackets. And this is how we create an if statement. So if we do, let's just do true like that. And we see that we get true as expected. If we change this to false, then we're not going to get anything. Okay, so if we want an else statement, we can add this either here or on a new line like this. I usually try to stick to this, but if the code above gets maybe particularly messy, if there's like a lot of code in there, it might be more readable to have it on a new line. It's up to you, either one works. So let's do false like this, and we can see this in action here. If we have another condition, we can also have an else if or an elif statement. We do this in the exact same way. Let's put this here. We want else space if. So we want the whole word else and then another if. This is a bit different from Python, where we use the contraction elif. I think a lot of other languages use contractions as well, similar ones. And we're just going to want to otherwise replicate the normal if statement. So we've got else and then if. We've got some brackets, and this is where our condition goes. And then let's do third option. So first condition is false, the second one is true. So because the first condition is false, then we do the else if. This one is true, and so we print out third, and then we can skip to the end, because this one was true, we don't care about the else. While loops are going to be very similar. We're going to want a Boolean condition, and then let's do while. After the while keyword, we want some brackets, and in here is where the condition goes. And let's just say print hi, and then set the condition to false. If we didn't have that condition equals false there, we'd obviously get a an infinite loop. But what if we want to run something at least once? So maybe this starts off as false. And in this case, we're not going to see hi a single time. What if we want to do something, and then if a condition is true, then we want to do it again? Well, one thing that we could do is set a condition to true like this, and then at the bottom of the while loop, we can modify the condition to what the actual thing that we're interested in maybe is number is greater than 10, or possibly more likely number is less than 10. Let's just change this back to condition false. And have a look at do while loops. So do while loops is exactly that. It's a cleaner way of doing something once, and then if a condition is true, then we do it again. Okay, so if we have Boolean condition equals false, we can do, and then we have the curly brackets here, and we can print out hi, and underneath while, and then we need normal brackets and condition, and then we need a semicolon after that. So this will always execute once, even though condition is false. Let's have a look at collection. So if we want a static array of integers, we can do that in the following way. If we have the int type, but we don't just want a single integer, we want an array of integers. And so we can denote that with the square brackets here like this. And let's just call this static array. And we can say that we want it to have 5 elements by doing the new keyword followed by int and 5, like that. Now, if we were to print the first value in the static array, we can do that by using the name and then the square bracket syntax with 0 as the first index. And if we were to run that, we get the value of 0. We haven't set that explicitly, but because we've used one of these primitive types, it will have a default value, and for integers that is 0. You need to be careful when you have a static array or any kind of array with a new item, because if you haven't initialized it, if you haven't given it a value, you might run into a null pointer error, and those can be a bit tricky to debug. But for now, integers give us a default value of 0, so we can ignore that. But maybe we want to, so in order to fill that in, for example, we would need to do static array 0 equals 5, and then when we run it, we've already got the value of 5 there. But what if we already know what we want to store in the array? We don't want to have to initialize it and then place all of the individual items in. Well, what we can do is, let me get rid of this terminal. We can do int, call it static array 2. And we don't need this anymore. We can just do curly brackets and start typing in values. And if we print out static array 2, index 1, we're going to get hopefully 3. So we get the 5 from the first static array and then the 3 that we want from here. If we want a dynamic array, an array that can change in size, an array that we can add values to, we need to use what Java calls an array list. So we type in array list and just call it dynamic array, and we need to do new array list like this. And as you can see from the top, sometimes your IDE will automatically add this for you. Other times you'll have to type it in. We've got import java.util.arraylist. So an array list isn't something that exists in the core language of Java. it's part of the standard library. So if we want to use it, we'll always be able to use it because it's part of the standard library, but we do have to import it. We have to tell Java that we want to use it. We also have another issue here, is that it doesn't know what type we want. So if we want a static array, we have to specify the type just here. We need to do the same for an array list, and we do that inside of these sometimes called angle brackets, and we can do that as integer here. We're not actually allowed, I don't think, to put the primitive types in here. We need to have the class version, so we need to do integer instead of just int. From there, we can do dynamic array dot, and we have a lot of these suggestions available to us. So we can get the size, we can see how many elements are already in there. We can add an item, so let's say 25. We need a semicolon at the end. And if we want to output that 25, we can retrieve it. It's going to be in the first element, or the 0th element, the 0th index. So dynamic array, and then we need to use dot get. We don't have access to the square bracket syntax anymore. We need to use dot get and then 0, like this. And we have the 25 there. And if you need to use a linked list, you can access it in the exact same way with import java.util linked list down here. So we've got two different types of for loop. We've got an iterative for loop, or a counting for loop, where we need to initialize a variable, or we don't necessarily need to initialize it inside of the for loop. We can do it out here. Let's do it inside. So we've got for, and we want int I, and we need a starting point. So we create a new variable I with a starting point of 0, and we want to repeat this loop until I is greater than or equal to 10. So we need to repeat it while I is less than 10. And at the end of every loop, we want to increment I by 1. So that's the syntax we use, and then we can just print out what I is at the current time and run this. So we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the I is going to increase to 10, which is no longer less than 10, and so we don't execute that iteration. We then move on to after the for loop, so let's add a new line, and then let's use the other kind of for loop, which is if we have a collection, we can take each item one at a time, a for each loop. So let's have an integer array, just call it array, with the values. Let's make it out of order to make it stand out from the other a bit more. And we can just do for, and let's do num. Let's get the terminal out of the way. We need to do, actually no, we need to add the type, so we need to do int num. Num is going to be an integer, and we use a colon to separate the actual collection itself. So we've got int num colon array, and just like any other variable, it's warning us that we haven't yet used it. So let's just print out num inside of here. I'm also just going to decrease this down to 5, so you should get 0, 1, 2, 3, 4, and then a new line, and 3, 2, 4, 1. So in order to create a function, we need to go outside of the main function. We need to stay within the current class though. So the first two words of the main class we can just copy over. We'll see exactly what those mean later on. The third word, however, this void, the void means that we don't want a return type. So if we do want a return type, for example, if we want to return an integer, we have to put int just here. Then the next word is going to be the name of the function. So maybe let's make a function that adds two numbers together. So add two nums. Then we've got some brackets. Inside of the brackets, we can put the arguments to the function. So maybe we want to take in the two numbers separately, a and b, and then we need some curly brackets just to finish off the function. Now we're currently getting an error because we've said that we are returning an integer and we haven't yet returned an integer. So if we just return 0 like this, the error will go away. I've got something else inside of VS Code, which is kind of like a dictionary. It's telling me it doesn't know what nums means. So I'm just going to add that to user settings to make it go away. So how do we call this function? Let's create two values, x and y down here. So maybe 4 and 5. And we want to get the sum of these two values. We want to add them together. And let's put it into z. Now, this is a very simple function. We could just do x plus y. But because we want to see how functions work, let's call this add two nums function. And it's actually put these values in for us. If it didn't, we would just need to type in the first variable that we want to pass in, which is the x, which has a value of 4, and the y, which has a value of 5. Okay, so the only issue is we haven't used the z variable, so maybe let's just print it out. And if we print out z, we are going to get a 0, because that's what we returned from the function. What we actually want to do to make this kind of correct is to return a plus b. And now if we run from main, we're going to create the two new variables, 4 and 5. We're going to pass them into the function. That's where we're going to add them together, and then we're going to return them straight away. So that's going to come from the function and go into z, and we're going to output the 9 just here. And finally, let's look at how to get some user input. So in order to get user input, there are lots of different ways to do it. I'm going to be using the scanner method, which means we need to import java.util.scanner. And scanner is a class that helps us with a lot of different things. So it's quite good because it helps you out with user input as well as reading and writing from, I think just reading from files, from text files. So it can be quite useful. So let's create a new scanner object. Let's call it just scan. Or in fact, let's call it input. Okay, and we need to do new scanner. And inside of the brackets here, we need to do system.in. This is a bit like system.out.println, but this time we want system in. Okay, so this kind of pattern here, we've got a data type, which is also or in this case it's a class, but it's acting as a data type. We've got our variable, and this pattern here will become a lot more familiar as we move through the course. Okay, so we've got this warning here, resource leak, input is never closed. And in Java, this isn't too critical. If you move to languages like C or C++, this kind of stuff becomes a bit more relevant. But just to make the compiler happy, let's add input.close down here. So Java has a garbage collector, which means all of this should be collected and sorted out for us. But there are some cases where it's nice to be a bit more explicit. We can clear it up ourselves. We don't have to leave it to the garbage collector to sort everything out. Okay, so now that we've got a scanner that is looking at system.in, we can start trying to get user input. So let's do string input equals, and we've got this input kind of object. We're going to look at this concept again a bit later, but we want input dot, and we have a lot of different options here. We have next int, we have next, and we have next line. Let's just do next line for now. And we can output the input again. So it doesn't look like anything's going on at the moment, but that's because we need to type something. And whatever we type, when we press enter, so next line is going to wait until we press enter, it's going to output the exact same thing. What if we want an integer? We could search for next int, or we could convert this to an integer. So if we have int, that's going to throw an error because we can't convert from a string to an integer implicitly. We have to do it explicitly. So let's do integer dot parse int. And there's a lot of stuff going on here, so let's just take all of this out. We want this string inside of it, and this should all work. But only if we do enter in a valid number. So if we were to add 1, we can see that this does act like a normal number. It's not just a string like it used to be. So if we enter a 5, it will give us a 6. But if we enter in a, it will throw an exception, which is a bit like an error, to say we can't turn a into a number. So we've gone through quite a lot today, and in particular, scanners and user input in Java are a bit tricky. But I don't suggest trying to memorize these concepts. As long as they make sense, you should be able to Google the syntax for what you're looking for. So, for example, I'm starting to get used to it now, but whenever I need to use user input from, well, pretty much any language, I always have to Google the language name and user input. And as long as you can find what you're looking for, you don't need to have it all committed to memory. If you start using certain things really often, so for example, while loops I use all the time, this syntax will automatically go into your brain and you won't have to look it up anymore. But for certain things like user input, or just anything in general as you're trying to learn, don't try to memorize everything, just try and do stuff. But with that said, in the next video, we're going to be looking at classes and objects.